related to the shift property is the zTransform of the shifted unit pulse. So the unit pulse is defined as delta of n is equal to 1 if n is equal to 0 and 0 elsewhere. So it's just a 0 sequence with a 1 at the time 0. So the zTransform is then the 1. So the zTransform of the shifted unit pulse. So if we have this unit pulse and then we shift by these samples, then we have that this zTransform is z to the power of minus d. So is what we have here is the zTransform of the shifted unit pulse. So if we shift the unit pulse by these samples, we have that is equals to z to the power of minus d. Another very important property is linearity. So if we multiply our sequence in the time domain by a value, let's say a, is also in the z domain we're multiplying by the same value. Or if we add two sequences in the time domain, is the same as adding these polynomials in the z domain. And of course the convolution is one of the most important mathematical tools in signal processing, and the zTransform turns a convolution into a multiplication. So a convolution of sequences in the time domain becomes a multiplication of polynomials in the z domain. So just remembering that the convolution is defined of this sum here, and this is because the convolution of two sequences behave in the same way as the multiplication of two polynomials, so the zTransform of the sequences. This is one of the main advantages of the zTransform, since it turns convolution into simple multiplication, which is in principle invertible.